Greetings and welcome, friends. We're on page 85, our homework quest. We're solving compound inequalities, multiple inequalities simultaneously occurring with an and or logic. So let's see, write a compound inequality that is represented by the graph. So this one is shaded in between. That is an and logic operator in effect for a compound inequality. I could write this as x is greater than -3 and x is less than or equal to 2. But I like, and actually I'd prefer if you do as well, so it's kind of like a mandatory suggestion here, write the and ones in least to greatest form. So -3, flip this around, is less than x is less than or equal to 2 is the way that you should write that. Where notice the solutions are in between those points, so x is in between those points. And in least to greatest, all of these become less than or variant signs. Yeah, so smallest number, the middle numbers, and then the biggest number, right? That's how it works. When it's shaded away, that's going to be OR logic. Actually, I just was in another math class yesterday, and someone said and means at, and or, I already forgot, meant something else. Out, right? So they point at each other, right? These shaded arrows would have pointed at each other, and these ones pointed out from each other. They described this situation as a pie problem, where everyone wants to go towards the pie. You want to be right close by the pie, whereas they describe this situation like a skunk at 5, and your safe zone away from the skunk is everywhere but near the skunk. All right, so that was kind of some of the explanations I saw while I was wandering through some other math classes yesterday, as you would, you know. So here we go. I'd have x is less than or equal to 4, or x is greater than 6. Now, the reason the OR logic has to apply here and not and is because a solution to this inequality would, like 3, for instance, makes this inequality true, but is not true for that inequality. 3 is not bigger than 6. So any solution on this in the solution set will only ever work for one of those inequalities. Whereas up here, any solution must work for both of the inequalities, like 0 is bigger than -3 and 0 is less than or equal to 2, okay, is a solution. However, like 4 is bigger than -3, but it is not less than or equal to 2, so therefore it is not in the common solution set when I apply the and logic. All right, good. Let's see. Question 7. A number p is less than 6 and greater than 2. So I see the and logic there at play. So let's see. P is less than 6 and P is greater than 2. There was the and logic, so I'm going to write this least to greatest. 2 is less than P is less than 6. Right there. Let's check this one out. Here we go. Now we're getting interesting. Solve the inequality, graph the solution. So here what we would do, get the variable by itself. So I would subtract 8 from both sides. Over here, all right, I just wrote plus. Meh. All right, I'll just do one at a time here, one at a time. V is less than -5. I didn't have to flip the inequality. Adding and subtracting we're cool with. Or over here, if I divide both sides by -8, right, to get the V by itself, it was currently being multiplied by -8, so the inverse operation is division. And what, yeah, I know. Or, yeah, the ors aren't lined up. V, flip that inequality because I divided by a negative, +5, and box it. Looks like I'm done. If I want to use my ruler tool, yes, here we go. Drawing a nice nombre line. Let's see, 0. Hey, 5 and negative 5 are equidistant from 0. I'll use purple, I guess. So let's see, this would have been an open circle at negative 5 shaded to the left, less than left, or open circle at positive 5 shaded to the right. Right. Greater than. Right. Good stuff. Good stuff. Let's see. I think, was that? No, I got one more. Perfect. All right. Describe and correct the error. Here we go. Here's a compound inequality, one of those AND cases where the variable's in between. Now, the way we said this yesterday was pretend as though this is not here, and how would I solve this inequality? So I would subtract 3 from both sides, and then just be like, oh, wait a minute, there's 3 sides. So you would have subtracted 3 from all sides. So let's see. Oh, I think I spotted their mistake already. 9 minus 3 is 6. This one would have just become negative 2x because those would have swiped out. And then I found their mistake right here. 4 minus 3 is 1. Right? So it looks like they forgot to subtract it from all 3 sides. And then we would have divided by negative dose. Negative dose. So they did that part correct, assuming they were right. They even remembered to flip the inequalities. Yeah, it'd be a half. I agree. So we would have had negative a half is greater than x is greater than negative 3. And then I would have written this from least to greatest. Negative 3 is less than x is less than negative a half, is what I would have done. Did they graph theirs correct? Yeah, x was between negative 3 and negative 2. Ours would have been similar, except our negative a half would have been over here. So something like that. Right? Good stuff. Good stuff. So yeah, when solving a compound inequality, when you've got your variable in between 2 sides, there's 3 sides total. You know, then you do your addition property, division property, subtraction, multiplication on all 3 sides. All right, very good. Thanks for watching, Internet friends. Have a great day.